All right, guys, it's a few minutes past 8 o'clock Eastern and 5 o'clock out west, so it's time to get started here for lesson one of the PowerScore Live online course. As you guys can probably tell with the little blue microphone next to my name that I am Eric. I am going to be your lead instructor for the next 10 lessons, and joining me, we actually have the pleasure of having two co-instructors, both Chris and Rachel, very, very talented, very, very competent instructors. They are definitely going to be your primary point of contact here for questions. We pride ourselves on making sure you guys get your questions answered. And we are always here, as you guys noticed tonight, we're always here a few minutes before somebody will be, and always will stick around for a few minutes after class to get any outstanding questions answered that you guys may have as well. Okay, guys, so getting into the pure sequencing game. So this is a specific game type. Really, guys, you could probably head this under the broader game type of a linear game. Probably over half of logic games fall into this linear category, which is really just about ordering variables into some kind of a sequence or order. We call it pure sequencing because it's really kind of describing these games. It's the games that have purely sequential rules in them, right? These are probably among the most monochromatic types of games that you have because they'll just keep hammering away with the same kind of rule over and over. It's a rule that talks about the relative position of variables with respect to each other, as opposed to ordering rules about the absolute positioning of variables, where they have to be or can't be, locking them in place next to each other, something like that. We don't see that typically from pure sequencing games. It's more of these ER words like faster, slower, taller, shorter. So it is about ordering these variables, but where are they relative to each other? Okay. How we represent these pure sequencing rules or these sequencing rules is just simply a dash. And imagine this game, guys, is we are ranking these variables, say 1 to 5 or something like that, fastest to slowest, ranking them by speed. Okay? So if we got a rule that said Paula is faster than Ty and slower than Sarah. Okay, well, that means in this sequence, Sarah is to the left of Paula, who is to the left of Ty. And that's exactly how you would read these dashes. Is you could read them faster than and faster than, but really, visually, it's Sarah is to the left of Paula is to the left of Ty. We want this sequence to match up with how we orient our diagram. Now, number 2 brings up a very important point that unless it is otherwise ruled out, and it has to be specifically ruled out, there is the possibility of ties. Okay, so if you have a rule that says Jaru is not faster than Miles, that doesn't mean Jaru is necessarily slower than Miles. Okay, so to accommodate that possibility of ties, guys, we just would do, instead of just the dash, we do this double dash that kind of looks like an elongated equal sign. But we would read this as Miles is to the left of or equal to Jaru. So if they haven't specifically ruled out ties, you would have to allow for that possibility. Now, most games, I will say this, guys, most games do explicitly rule out ties, but you can't assume that they're ruled out. You have to wait till the game actually says it. That's the trick. Now, number 3, and this is a good rule of thumb for logic games generally, always look for rules that involve common terms, okay, shared terms, because odds are you can probably connect those rules and make inferences based on those connections. So we've got the Miles is faster than or equal to Jaru. That's pulled from above. But if Miles is also slower than Noguchi, well, that means Noguchi is faster than Miles, who is faster than or equal to Jaru. And so that would allow you to therefore make the inference here that Noguchi would have to be faster than Jaru because of that chain that you've drawn. Number 4, always keep an eye on the limits of the game. Who can be fastest, who can be slowest, basically who can be first and last. 2 reasons for that, guys. Number 1, the first and last positions tend to be more restricted than other positions. So there tends to be more inferences about them. And secondly, they like to ask a lot of questions about the first and last position. So you're anticipating where questions are very likely to go. Now, as we get into number 5, 6, and 7, guys, this starts to slow down a little bit because these are a bit trickier patterns that can come up within sequencing games. So number 5, be careful with rules such as this. Ty is faster than both Vernon and Wendy. Okay. It's very easy because of the order in which those terms are presented in that wording to draw this rule something like so. That Ty is faster than both Vernon and Wendy because Wendy was written after Vernon. it's easy for your brain to kind of go here. But this isn't what they're saying, right? Ty is faster than Vernon. That's true. And Ty is faster than Wendy. That's true. But we don't actually know the relationship between Vernon and Wendy. So that's the big problem here. So you want to make sure if they give you a rule like this that you draw it appropriately so that you're not going to make any inferences that don't exist. So that's where we come in with this, what we call the double-branched vertical example. And V and W are kind of written parallel to each other, that there's no line connecting them, so you're not wanting to impart a relationship between them that doesn't necessarily exist. Okay, and that can go both ways, as you see here. And in fact, it can even, you can get to like triple and quadruple branch examples. If it says Vernon, Wendy, and Zazie are all faster than Ty, well, you've got all these connections of each of these variables to Ty, but you want to make sure you're not drawing any connections between them, because we really don't know the order of them. So again, it's about knowing what you know and drawing that in, but making sure you're representing the rule in a way that you're not inferring things that don't exist. Now, number 6, this is actually going to be pretty common to see things like this. You often will get games in which all of the rules, or most of the rules at least, will chain together into some pretty big mass of sequencing rules. So here, the first rule, Sarah is faster than Paula, who's faster than Ty. Second rule says Ty is faster than Noguchi. Last rule says Noguchi is faster than Miles. And then this third rule says Miles is either faster than or equal to Jaru. So all of that links up like so. Okay? But now let's say you get like a local question that says, well, what if Fuad is faster than Ty? Okay? Well, if you're trying to make the proper inferences from that, guys, you got to make sure and represent it accurately. So Fuad is faster than Ty. Make sure you draw another, basically a double branch vertical off of this chain. And if Fuad is faster than Ty, that definitely proves that he's faster than all these people that are also slower than Ty. So we can make those inferences legitimately. But you got to be careful in how you draw this, because even though Fuad is faster than Ty, where is he in relation to Paula or Sarah? He could be before both of them. He could be in between them. He could be after them. We really don't know. And we want to make sure, again, that we draw that rule in a way that we don't make inferences that don't exist. Then lastly, guys, in this number 7, we're not going to see this in the games that we have here tonight, but this is one of the trickiest. I would definitely make a note of this, guys. This is one of the trickiest, I think, patterns you will see in any pure sequencing game. So make a note of it. This is also one you may have to come back and watch on the recording here. But at first glance, I think what's so tricky about this, guys, is at first glance, it seems pretty straightforward. So say you have a rule that says B is faster than D, or else C is faster than D, but not both. And I'm going to say here, guys, let's say that they did explicitly say no ties. For this to work, they would have to. Okay, so let's imagine that's there. Now, at first glance, this is why I said it's easy. Most people would just draw it like this and say, okay, pretty straightforward. It's B before D, or it's C before D. Seems easy enough. But there's a little bit more than meets the eye to this rule because of this final clause. It's saying it's one or the other, but not both. And what that implies is that if you are one, you're not the other. So let's take the first scenario. Let's say B is faster than D. Well, that's going to prove that C is not faster than D. Right? And if there's no ties, then what does that really mean, guys? What does C is not faster than D equate to if no ties are allowed? It's going to say that D has to be faster than C. Okay? And so if B is faster than D, that implies D is faster than C. And so we can put that actually on the end of that chain, like so. Meanwhile, in the other scenario, if C is faster than D, this phrase implies that therefore B wouldn't be faster than D. And again, as I said before, if that is true and there are no ties, that would equate to D would have to be faster than B. And that we could put on the end of the second chain. And even though you still don't know which one is going on, guys, the one universal truth about both of those is that D is always in between two people. And that would tell you that D can never be first or last, no matter what. And that is a big inference that's almost always tested in games that have that pattern. It's not very common. I will say this, guys. Number 7 is not that common. Not a very strong likelihood that you would see it on your test. But let me say this. If it comes up in a sequencing game, pretty much a guarantee it's not an easy game. It may not be a hard game, but it's not easy. It's at least middle difficulty. And secondly, this rule is going to be a pretty big driver of what's going on in the game. The last two are pretty quick. Number 8, you usually are just going to see a collection of sequencing rules in these games, guys, but every now and again they'll throw in this other rule that may not be sequencing, something like Wendy can't be fastest. Just toss that in. Well, one way to deal with that is to just circle Wendy as kind of a special variable within the game, that it has this outside restriction, almost like kind of tying a little string around your finger, don't forget. But usually you're not going to see more than 1 or 2 variables that have that, so that's just kind of a quick way to remember. Number 9 is a big one for me. I have to get up on my soapbox for number 9 because they say it here, the key to superior performance on sequencing games. But guys, I'd really highlight this because I'm taking out the word sequencing. I would say this is the key to superior performance on games, period. And the book points it out or calls it avoid making unwarranted assumptions. And I agree with that, but I think there's maybe a simpler way to say it, guys. But the way I would describe this is the key to superior performance on games, guys. It's not about seeing every single inference that the game presents to you or that is available to you. Obviously, throughout this process, we are trying to see more and more inferences and be better and better at that. But what kills you in a logic game is not the inference you didn't see. It's the inference you made that didn't exist. Okay? So you're far better off, guys, to miss a couple of inferences, but to be dead on accurate with what you did see, than to be, thorough and see all the inferences that are there, but add a couple that weren't actually true. That's the kiss of death on logic games. And if you're pressing so hard to see so much over and over, guys, that you're making mistakes and you're identifying things that aren't actually true, that poisons your questions. It's not going to mean that you're not going to get anything right, but it definitely can haunt a lot of what you do. If you don't see everything, but you're seeing the basics and you're getting better, and maybe you miss an inference here and there, usually you can pull that up in the questions a lot of times. It's not always going to be the end of the world. In fact, guys, I still to this day don't see all the inferences in most games, especially the more difficult ones. Basic games, yeah, probably see all the ones that are pretty relevant, but harder games, I'm going to see the basics. I'm going to see, maybe some very insightful inferences, but there's a lot of tricky ones I may not catch because they just don't have time. You got to get into the questions to get points. Maybe those inferences don't come up. Maybe they only come up once, and I can just spend more time on the question finding it. Okay, but don't press so hard, guys, that you're sloppy and you're making mistakes. That is a problem. Okay, so really look to avoid that. Okay, let's take a look at game number 1.